Hey everybody, this is Dr. Maples. Let's get started doing some basic analytics today. So, in this previous lecture, we learned how to open RStudio, we learned how to open our data set, and we learned to look at our variables and our code book. You probably also, I hope, spend some time getting familiar with that code book in between lectures, so that'll make things a little easier for you today. If you haven't done that, go back and get that code book from Blackboard. It's in course documents right there with your data set. Make sure and get that. Take a look at it so you're a little more familiar with the variables that we're going to be working with. Now, R can do some really simple tasks, and that's how we're going to introduce ourselves to it, learning to do things like find the minimum value, the maximum value, and the average score. So we're going to learn some really basic things, and I'll walk you through how to do that. Let's pretend that I want to find the lowest score in the data set. Now, first off, we're going to use a command, min, M-I-N, and then we're going to put something in parentheses. So min is, go ahead and just type that into your RStudio there along that command line, M-I-N, and then you can put a space, and then we're going to see parentheses will automatically pop up when you put in your min there. The little parentheses will pop up. And in there, we're going to put in the name of the data set first, and then we're going to put a $sign. And behind that $sign, we're going to put the variable that we're interested in. Now, start to type in the name of the data set. It's final grade prediction data set. 99 times out of 100, as you type in, about the time you get to the word final, it'll usually pop up in RStudio. And it'll say, oh yeah, we know what you mean. Did you mean one of these? And you can just click on it. Now, you have to put the name of the data set in every time exactly as it is, because it wants to know exactly what you're asking it to do. And then you're going to put a $sign in. Why a $sign? Well, that $sign is a character that's used to tell us the difference between the dataset name and the variable name. So we first have put in the dataset name, now we put our $sign, and as you start to type in score, 99 times out of 100, it'll also say, oh, do you mean one of these variables? And you can just click on it. And make sure it's in parentheses. So the example is right here in the PowerPoint. You can download the PowerPoint and you can literally cut and paste this into RStudio. And if you have your data set open, everything will work out and it'll give you the min score. Min is the command that gives us the minimum score. So you tell me, what was the minimum score on that exam? Well, when we run that, it'll look something like this. In fact, it gives us a very simple output that says 40. The lowest score was a 40. Now you can see there exactly how I pasted in the text, min, parentheses, final grade prediction data set with the little underscores in there, and then the $sign to let me know that's the name of the data set, and now I'm going to put in the variable name score, and it tells me the lowest score was a 40. Congratulations, you've done the very first thing on your coding career. Feels pretty good, huh? You told the computer exactly what you needed it to do using language that it understands. Isn't that awesome? Congratulations. It feels good. Take a moment, pause that video and say, I'm pretty awesome. It's like a little affirmative moment here. Let's learn some other things. Lowest score was a 40. Oh boy, what was the highest score? Let's change the word min to max. Now, depending on what your computer allows, PCs using Windows, you can usually hit down on the arrow key and it will actually pull up your old commands, and then you can edit your old commands. That's really useful, by the way, too. If you make a mistake, you can hit down and then you can fix whatever your mistake was. But try that out. See if it pulls up min, final grade prediction, $sign score. And if it did, go ahead and change the word min to max, M-A-X. If not, you can cut and paste it and then fix this by just going back to min and typing in max. Let's find out what the maximum score is. So if we run max, parentheses, final grade prediction data set, $sign, score in parentheses, we will get the maximum score was 100. And in this screen, note that the very bottom is where I show the 100. And then at the top, it also actually shows the data set itself that I happen to have open in this picture. So there you go. We've got some really cool, interesting information already. So wow, pretty neat, huh? Now, 100 was our highest score. It looks like you only had one person that got that. How about the middle score? Now, middle score is different than the mean score. Mean score means the average of all the scores. The middle score is the middle score, literally, that's in the middle. So it's very different than mean. If we type in median, where we typed in max, we'll actually get a different thing. So go ahead and hit down or copy and paste so that you can change your old command of max and replace the word max with median. Now let's see what the median score was. We have the min, the max, and now the median score was 75. Middle ground was 75. Interesting. How about mean score, where we figure out the actual average score? We changed the word median to mean, and now we find that the mean score was a 77. In these handful of easy steps, you've already learned the basics of R. You've learned how to talk to the computer to do some very simple, basic steps. So now that we've learned some basic things, let's take that a notch further and start to learn to interact with some of these other variables. We've learned min, max, median, and mean, very useful things. What if we want to learn about some of the variables and what we can learn about them? So for example, there's a variable in there that's called a CAD group. Now, a CAD group tells us if a person was a fresh person, sophomore, junior, or senior. What if I need to know how frequently those people are represented in this data set? Or maybe even if I wanted to know how many people got a 40 and how many people got 100. Well, we can use a command called table to do that very same thing. So we'll hit the down button again, and now we can change where we put in mean, and we've previously put in min, max, and median. We're going to change that mean to the word table. And what table is going to do is it's going to give us a little simple table of a data set and a variable to let us know how it's measured and how many cases fall into each of these. Now, we'll change our variable name here. We'll still have the data set, a final grade prediction data set. We're going to hit $sign. We're going to put in a CAD group, and that's spelled A-C-A-D, a CAD, and group, G-R-O-U-P, one word. So now we have table, parentheses, final grade prediction data set, $sign, a CAD group in parentheses. So now what we're telling R to do is go into this final grade prediction data set, find the variable a CAD group, and put it into a table for me so I know what all these scores mean. When we do that, as you see on the output on this PowerPoint slide, it now tells us that we had 91 fresh persons, 53 sophomores, 42 juniors, and 54 seniors in the class. Pretty cool. Now, how do I know that? 1, 2, 3, 4 suddenly means fresh person, sophomore, junior, and senior, right? Remember the code book? If we go back to the code book, it tells us that a 1 equal to fresh person, 2 equal to sophomore, 3 equal to junior, and 4 equal to senior. That's how we know that. So when we see number 1 and a 91 below it, then that means category 1, fresh person, had 91 people in it. Pretty exciting stuff, huh? What if we wanted to do a little bit more and find out how often a value occurred on something else? What if I wanted to know how many students had a job during the semester? Well, we can use the table command again, and I particularly chose this variable and spelled it the way I did because it's got a capital J in it that matters, so pay close attention on this one. We can hit down, and we've got our table command pops back up, but let's change the variable from a CAD group to job status. And when you put in the J, make sure it's a capital J because R is looking for the exact name the way it's listed. Now, this is a learning lesson because I want you to note that capital letters can be a real problem on these data sets. So always, always, always in the future when you're building a data set, don't put a capital in there, unless in this case when it's a teaching tool, but keep them all as lowercase. But watch for that for other people's data sets you might use because that capital letter will be the difference. It wants to find that capital letter. Now, there may be updates that it would think that job status with a capital J and a lower j are the same thing, but the version that you're downloading right now probably thinks that a capital J is unique from a lowercase j. So make sure and put that in. But it gives us the answer, right? We put in a table in parentheses, final grade prediction data set, $sign. We put in our variable name job status, close our parentheses, and when we hit enter, we find out that there were 132 people in category 0 and 108 people in category 1. And if we go back to our code book, we know, the Word document, we know that there 1 means that they had a job during the semester, and a 0 meant that they didn't. So 132 people didn't have a job, and the code book tells me that 1 equals job, so 108 people did have a job. Simple, straightforward, basic stuff, right? Pretty cool, huh? Now we can also look at how variables change together, and this is our last thing that we'll do in this lecture. We can use this table command to put in multiple variables, so we don't have to just, do one at a time. We can actually do more. It's interesting because what do you think might happen if a person has a job? Do you think their score might be impacted by having a job? I could see that. How many of you have a job? And think about how that might impact your score on an exam. If you don't have a job, you might have more time to study. If you have a job, you probably have less time overall to study. So it seems like maybe having a job could impact that. So let's list these together using table and learn to do some really interesting basic analyses. So we'll type in table as we always have. You can hit the down button. You can leave in final grade prediction data set, put in a $sign, and let's put in score. So let's go back to our score data set. And here's what I want you to do. After you have final grade prediction data set, $sign, score, put in a comma. And then we're going to put in final grade prediction data set again because we're going to tell it a different variable. We're going to hit the $sign, and we're going to put in job status with a capital J, because remember that capital J matters. So now what we're doing is we're putting these in a list, and we're telling them, give us a table and put these two things together. We basically have the command table, then we have one variable, comma, another variable. And you can list multiple variables this way, so we can see how they have a relationship between them. Let's do that now. If we get the output for that, we can now see people who are in the 0 category, how they scored overall, and the people in the 1 category, how they scored overall. And this happens to be enough cases to give us all of the grade ranges and see where they all fell. So for example, we can see it looks like people in the 0 category didn't have jobs. We can guess that their kind of median scores really start falling. See, there's that 12 around 68, 75 with a 24 with a 75. But it seems like the upper grades, the 80s and 90s, you see a lot more cases. In fact, in 97s amongst people who didn't have jobs. Look at the people that do have jobs, however. We see far more of them in the fail columns in the 40s and 50s. Lots of 65s, 12 in the 68. And in fact, as you get into the upper 90s, you see relatively few. So we can kind of see that it looks like there's a difference there. Gosh, but you know what? Wouldn't it be really helpful if maybe we could, see just the plain old mean scores? That might be a lot easier because this seems really confusing. It gives you this output and it's kind of useful, but wouldn't it be simple if we just knew what the mean score was for people in the 0 column and the mean score for the people in the 1 column? Well, let's add one final command today, and let's do just that. Let's add in something called the t-test command. And we're going to use this t-test command multiple times, but for today, we're going to just use the simple version of it. We're going to put in t.ttest, and then we're going to put in parentheses, just like we did on our table here, 2 variables. But the difference is we're going to put a tilde in between them instead of the comma. If we put in the comma, it gives us a different result that's not really useful. It just tells us the means of those 2 variables. But if we put in a tilde, it'll tell us to kind of compare being in category 1 and category 0 and category 1, and then what the mean score would be for those. So the tilde, for those that don't know, it's usually located in the upper left end of your keyboard. You can also just copy and paste it if that's helpful. What we'll do is we put in t.ttest, and then we put in parentheses, final grade prediction dataset, $sign score, we put our tilde, and then we put in final grade prediction dataset, $sign job status with a capital J. And note that what it's going to do now is tell us what the average scores are based on job status. Now, a quick thing, if you put these in reverse order, it would be problematic because it's going to try to do something really weird. Here, by putting that dichotomous dummy job status variable, it's a 0 and a 1, in the second column here, or second in this list, it's going to take the average score and then it's going to split them up based on your job statuses. And so if you put them in the other order, it would be weird. It wants that categorical variable, the dichotomous dummy, at the end. So make sure and do that. And lo and behold, here I've hit enter, just like you'll see, and you can see what the averages were. In fact, we see that for group 0, people who didn't have a job, they averaged a 70. I'm sorry, an 82. I'm looking at the wrong column. People without a job averaged an 82 on the final exam, and people that did have a job averaged a 70. So that's a pretty big difference. That's exciting, isn't it? Now here's where I want you to get involved in this data set. I want you to get on the discussion board and talk about some of the variables that you want to describe. I want you to pick 5 variables from the list, and I want you to tell me their min, max, and mean or median. You pick whichever one that you want. And then I want you to play around with how things like having a job might impact other things like having a score, or how having kids might be linked to absences. It's your call, but I want you to play around with those. But you pick some variables, give me the min, min, max, and median or mean, your call, or both if you want. And then find some of these dichotomous dummy variables in the data set and tell me how they might shape other variables. There's a couple in there. Now, if you have questions about this, you let me know, but the discussion section will give us a chance to play around with this data set. In our next lecture, we're going to take this a step further and try to understand statistical differences that will help us test hypotheses. So if you have questions, you let me know. Otherwise, I'll see you in the next lecture. Go in that discussion section and get to work on that. Take care. See ya.